Hello, everyone. Happy birthday, Einstein. And it's Pi Day, too. We're sitting here in New York City, 14th of March, 2016. And Einstein was born 14th of March, 1879. So we're celebrating a genius. Time magazine called Einstein Man of the Century. He was not only incredible in physics, but he was politically active. He was a philosopher. He got into all kinds of intellectual pursuits. And he revolutionized not only one area of physics, but several. So let's explore a little bit why Einstein was such a genius and such a remarkable human being. But first of all, let me tell you that if you have any questions, please tweet your questions at us through the Twitter handle Albert Einstein, and also through my Twitter handle, Debbie Bere, D-E-B-B-I-E-B-E-R-E. My name is Deborah Berebichez, and I'm a physicist. I got my PhD from Stanford University, and I'm also a science communicator. I'm currently the host of Outrageous Acts of Science on the Science Channel and also on Discovery Channel all over the world. I'm also a data scientist at Metis. And so please, also on Facebook, live, right on this page, on Albert Einstein, send us your favorite quote, send us any question you have about anything Einstein related, and I'll be happy to try to answer as many questions as I get. So why was Einstein such a genius? First of all, let's explore his scientific accomplishments. He actually got the Nobel Prize not for his remarkable theory of special or general relativity, but he got it for his contributions to theoretical physics, and he got it for the photoelectric effect. So what is that? Einstein discovered that there were some experiments where they had a sheet of metal and UV rays, light, or UV light was being pointed at this sheet of metal. And some electrons that were sort of weakly bounded on that sheet of metal would all of a sudden get excited enough to get unbounded, and they would just shoot out of the sheet of metal, which was pretty strange because for the classical theory at the time, Newtonian, could not really explain things. Why? Why was this strange? Because it turned out that there needed to be a certain frequency of the UV reaching the metal, the sheet of metal, a specific UV, a specific frequency for this to happen. And that's kind of odd, because if you think of waves in the classical sense, let's just think of water waves in the ocean. If you think of having, let's say, a log of wood in the middle of the ocean, no matter how frequent the waves are, that is, they can be, once every hour or once every second, if the magnitude, the amplitude of the wave is high enough, that log of wood is going to move no matter what. However, in the case of a sheet of metal where we were shining UV light to it, you needed a specific frequency above which the electrons become unbounded and shoot out. Why is that? So Einstein realized that what was happening is that light was not only a wave in the classical sense, but it came in quanta. That is, in packets of energy, and that the frequency of the wave was related to the energy of this quanta, which now we call photons. And so if the photons did not have enough frequency, meaning enough energy, they just could not make these electrons unbounded, and they couldn't escape the sheet of metal. That's the photoelectric effect. And that was an incredible discovery because it laid the foundations for the quantum theory of the small subatomic world. So that was one of Einstein's main discoveries, and for which he got the Nobel Prize in 1921, the nomination, and then he received it in 1922. Now let's go on to his second incredible discovery, which was a special theory of relativity. So Einstein thought that, according to Galilean relativity, if you are in a stationary environment, let's say you're just on the street and you're completely stationary and you just throw a ball to the floor, you let it go, the same exact thing should happen if you're traveling at constant speed in, let's say, a boat. at a very small, on a beautiful, calm lake at a very slow, constant speed. The same effect should be observed. So that was good for classical mechanics. However, there was one problem with the laws of electromagnetism that Maxwell had elucidated. When you come to electromagnetism and all the effects of electricity and magnetism, it's not so simple. It gets a little bit more complicated. And they differ, what the effects, according to these mathematical equations, the effects would be different for a stationary person on Earth, just, stationary on a say, like the shore of the lake. And they would be different as the effects observed by somebody traveling on the boat, moving at constant velocity. So Einstein realized this does not agree with experiments. This doesn't agree with reality, because what we observe is electricity and magnetism actually behave the same, both in a boat that's traveling at constant velocity, as well as in a stationary platform. So we needed to put together Newtonian mechanics with the laws of electromagnetism by Maxwell. And that was a very big feat in physics. And Einstein worked really hard, and incredibly, he found the special theory of relativity. And what he did to arrive at that was he actually had two assumptions. One of them was that the laws of physics, mechanics, and electromagnetism are the same for everyone in a stationary frame of reference or moving at constant speed. They should be exactly the same. That's reasonable because we see that. However, the second assumption that he had to put forth in order to reconcile these two fields was that the speed of light in vacuum had to be exactly the same for somebody who was stationary as well as for somebody that was moving at constant speed. And that seems a little bit crazy. It's counterintuitive, because if we think about it, when we are, let's say a train is coming at 20 miles per hour towards me, and I'm running towards the train at 5 miles per hour, I'm going to experience the train's speed higher, and I'm going to add those two velocities, and I'm going to experience the speed as 25 miles per hour. Similarly, if a train is running away from me at 20 miles per hour, and I'm running away from it at 5 miles per hour, I'm going to subtract that, and I'm going to experience the speed of the train when I look back as 15 miles per hour. However, light was completely different. The speed of light in vacuum was the same. Whether I ran towards the flashlight or I ran away from the flashlight, the speed was the same. That was special theory of relativity. And that had very strange consequences, like time dilation, Lorentz contraction. Time dilation means that for a moving observer, time passes by slower than for a stationary one. And that leads to the twin paradox, which is a wonderful thought experiment that Einstein came up with. And we can talk about that a little bit more later. But let me tell you also about the general theory of relativity. So Einstein didn't really stop there. He continued and he said, okay, everything looks beautiful. And if your mind hasn't blown up yet by all these strange consequences, what is going to blow your mind is general theory of relativity. Because Einstein didn't just stop at things that are stationary or moving at constant velocity. He went further and he said, what happens to acceleration? What is gravity? And there was an essential question. Is inertial acceleration, meaning like, for example, when I'm in a car and I press on the accelerator and I go really fast, I know that I'm accelerating because I get pushed all the way back. And if I have a coffee cup or something that's not secured in the car, it's going to fly all the way back. So is that equivalent to gravitational force, to the force that Newton had discovered that made the planets orbit around the sun? And so this equivalence principle of inertial mass with gravitational mass is one huge leap in physics that Einstein did. And so he thought that in general relativity, the predictions, by the way, have been tested for special relativity. And we just recently, with the LIGO, the Laser Interferometer Gravitational Waves Observatory, has just discovered in September of 2015 that we observed gravitational waves for the first time. And the discovery was announced on the 11th of February of 2016. So what happens in general relativity is that you can't really distinguish gravity from that acceleration. But let me give you an example. So if you have a really large mass, and what happens with that really large mass in the universe is that as it moves or as something happens to it, it modifies the space-time continuum. So up until Einstein, we thought, and Newton thought, that time was an absolute, that it didn't matter, if you were traveling or not, everybody experienced time the same way. Remember, special relativity said that moving people experience time more slowly. And so that changed things. So in general relativity, if you, I like John Wheeler's phrase, and this is what I was looking for right here in my notes, because he said something really beautiful. He said, matter tells space how to curve, and space tells matter how to move. Let me explain that to you. Let's say that you take your kids and you want to explain to them general relativity. So you take a towel, just a regular towel, and you really stretch it. And 4 people are grabbing like 4 edges of the towel. And you really stretch it very, very far. And then you put an object that's quite heavy right in the middle of this towel at the center. Let's first say that if I have a small marble ball and I just let it roll on the towel before I put a heavy object in it, it's just going to follow a straight line from one place to the other. Actually, that's only if I tilt it and I give it a little bit of gravity in order to go downwards. But if I put a heavy object in the center of it, as you see, the towel is representing space itself, and space changes. It gets curved because of that object. There's an indentation, and as you can see, if you have a ball in the middle, the towel bends, and that's exactly what happens to space-time itself by having large masses, such as planets, black holes in the universe, etc. And now, what happens is if I have the same marble ball and now I let it roll, it's not going to go from one side of the towel to the other in a straight path. It's actually going to accelerate downwards in a spiral motion. And that is because matter has curved space. That is the iPhone or the ball, whatever I put in the middle of the towel, curved the towel, which is space-time itself. And now that space has a specific curvature. So now space tells matter, that marble ball, how to move. Instead of moving on a straight line, it tells it how to move. So how do we know this is true? There's an incredible experiment called LIGO, like I just mentioned, this interferometer. And there are 2 stations in the US, one in Louisiana, another one in Washington, and there's one in Europe. And if something happened with a very large mass, such as a black hole starting to move around another black hole or whatnot, that sends ripples into the space-time continuum. And those ripples travel at the speed of light. And those were predicted by Einstein as gravitational waves. And at some point, they should arrive at the Earth, and we should be able to measure them. And that's exactly what happened. Through an experiment that had 2 beams of light and is an interferometer, so it measures the difference in phase between 2 waves coming back and forth at the same point. And the incredible thing is that it measured the merging of 2 black holes that happened 13 billion years ago. I'm sorry, 1.3 billion years ago. That event took this much time, 1.3 billion light years, to arrive at Earth, and we measured it, And we knew the size of that measurement is about 1,000th of a proton. That is 1,000 times smaller than the size of a proton. And this incredibly precise experiment was able to measure that. And so now we know that gravitational waves exist. So Einstein was right. And we just celebrated last year, 100 years of his general theory of relativity. And so it's incredible that just a year after that, we're confirming that gravitational waves exist. So thank you all for your incredible questions. I'm seeing a lot of activity here. And again, please send us your favorite quotes, favorite questions, anything you want to know about Einstein, his life, his physics. Again, if you have any questions after our live stream, you can follow us at Albert Einstein on Twitter or at Debbie Bere. That is DEBBIEBERE. And again, we can answer as many questions as we get. So let's see. I'm going to go and tackle some questions here. Okay. So what did Einstein say about the twin paradox? Okay, so I actually was going to explain that. So what happens with the twin paradox is that if you think of the special theory of relativity, if there's, let's say, a set of twins, and one of they're identical, and one of them is on Earth, and the other one decides to take a rocket into space and travel for many, many years. And then, because that twin will be traveling, if that twin later turns back and comes back to Earth, if the special theory of relativity is true, then when that twin comes back to Earth, he or she would be a lot younger, because we just said that in the special theory of relativity says that time will be slower, or will pass by more slowly for the person traveling. But the paradox is that the twin who is actually traveling in the rocket can say to the twin on Earth, you know what? For me, for my reference, you're the one traveling. I'm stationary, and I see you and the Earth moving away from me. So why isn't it that you on Earth are going to experience time more slowly, and therefore you're going to be the younger one when I come back? And the way we resolve in physics the twin paradox is simply by the fact that when you move and you accelerate, because the rocket has to accelerate to start speeding up, then it has to decelerate to slow down and be able to turn around and come back to Earth, and then it decelerates again as it moves back into the Earth atmosphere. And so in reality, the person accelerating, the twin, is experiencing that acceleration. And so it is the twin that travels in the rocket space that's going to age more slowly and thus be the younger one. And that's how Einstein broke the paradox. Let's see other questions. I've been wanting to learn more. Any advice on where to start? Well, Einstein is an incredible figure. He published 300 scientific articles and 150 other articles not related to science. So, you know, we also know Brownian motion and molecular motion. He laid the foundations, again, for quantum mechanics. He did so many incredible things that I would say just start reading. The archives of Einstein are open. A lot of his papers are public, so just try to read you know, all the main articles. In fact, I would strive to read the original ones and see what you can conclude. And there's plenty of people and videos out there that can explain them to you. Let me see. Is there something faster than light? That's a great question. There isn't. So I watched a great video last night by Minute Physics. And so it depends on what you're talking about. Because if you're talking about phase velocity, then yes, that can be faster than light. What does that mean? Nothing, no actual physical object with mass can travel faster than the speed of light. That is for sure the limit of our theories. However, if, for example, you have a laser beam and you shine it at the moon at night, and you go from one side of the moon that you're seeing the circle, and all the way you flick your wrist and you shine it all the way to the other side, that arc, because it's so much further away from you that the laser pointer that you're going to have, it's going to cross that arc of the moon much faster than the laser in your hand. And so we say that that phase velocity or that arc velocity can be faster, but that does not mean that any information, such as the photons, are traveling from one side of the moon to the other faster than light. So yes, the speed of light is a maximum, and it's 3 times 10 to the 8 meters per second. So it's super, super fast. Just to give you an idea, sound, the speed of sound in air is about 343 meters per second. That's how fast my voice is traveling towards the recorder here. Let's see. Can gravitational waves cancel each other out and cause an abnormality, perhaps an abnormality in space-time? I'm not sure how to answer that question. Definitely, like all waves, they can interfere with each other, and there are constructive and destructive interference patterns that can, but my expertise does not reach that far, so I don't know what would happen if with the space-time continuum once the fabric of space changes with that. Let's see. Let's see. What other questions? There's more than one property to light, though, right? Yes, there are several properties of light. We used to think with Newtonian mechanics that light was simply a wave, but quantum mechanics, which is still pretty strange, even though it's a validated theory, and it's a theory that's true to a precision that is extremely high, tells us that depending on what experiments we carry out with light, we can experience light as both a wave and a particle. As a wave, it sort of, with a flashlight, it sort of expands outward, and it has ripples, and we have interference patterns and whatnot. But as a quanta of light, as particles, such as photons that have no mass and travel at the speed of light, we also, depending on the experiment, can measure the quantized nature of light. So yes, it's 2 things. So let's see, what other questions do we have here? Why is Einstein considered a genius? So I think nowadays we have to focus on very narrow fields of physics, or even in any science, in biology or chemistry, or even within our professions. But Einstein blew us out of the water because he not only contributed to the theory of quantum mechanics, but he contributed to cosmology, to astronomy, to molecular motion. And there's also an understanding by the public that Einstein said that the theory of quantum mechanics was not true. Einstein, to my knowledge, said that it wasn't complete. That is, the strange theory that tells us that subatomic particles can be both a particle and a wave. He believed in the predictions at the time, but I don't think he felt that the theory was complete. He felt there was something more. And it's been investigated, and we now know that all the experimental measurements match very, very well our theoretical predictions. So it's an incredible theory of nature, and we know now that it's true. Let's see, what other question? Did Albert Einstein receive his information from a higher source? I don't know that he did, but if he did, I think all of us would like to be connected with that higher source. Let's see, what are some crazy facts about Einstein? I think there's so many, but one of my favorites is that Einstein loved to sail, but he didn't know how to swim. So there was actually, I read that there was an incident where he almost drowned, which I thought that was crazy. Let's see, did Einstein ever get married? Yes, Einstein married twice in his lifetime. First with Milena, And he had one daughter who is a mystery because that was before they got married, and she lived with the maternal grandparents. And as much as I've looked for answers and people have looked for answers, nobody knows what happened to her. And then they have, once they got married, 2 sons, Eduard and Hans. And Eduard unfortunately ended up being diagnosed with a mental health disorder and spent most of his lifetime in an asylum. And Hans did have a lot of kids and grandkids, and the family still carries the last name. So he did have a family. Wow, so many of you that we crashed the server. I'm really sorry. We're back live on our Happy Birthday Einstein event, 14th of March, 2016 in New York City. I see, yeah. So we were fielding questions. Again, we have 5 more minutes, but if you have any other questions, please, you can post them here on our Facebook page, Albert Einstein, or you can tweet with a hashtag Happy Birthday Happy Birthday Einstein. And you can also reach us on Twitter. My Twitter handle is Debbie Bere, that is DEBBIEBERE. And Albert Einstein is the other Twitter handle. Again, I'm host of Outrageous Acts of Science on the Science Channel on Discovery, and data scientist at Metis. So for physicists, why was Einstein so important? Did he ever take an IQ test? So we know that he was extremely important because, I guess the question here is, where is the Einstein of today? So that's an excellent question. And the truth is that nowadays we're, like I said before, much more narrowly focused. And so an Einstein of today would have to cross interdisciplinarity and contribute to many different fields in physics. So not only would he or she have to contribute to cosmology, but also to a theory, the Standard Model, or string theory, or the theory of quantum mechanics, etc. So it's definitely a much harder task. And so Einstein was such a genius because he broke the barriers of all this interdisciplinarity, and he contributed to everything. So here we get a question. Was Einstein left-handed? No, he wasn't, actually. He was right-handed. So that's something I happen to know, which I think it's funny. There's still, can we predict the future use of any theory of Albert? Absolutely. Actually, the very fact that we use the GPS on our cell phones is a consequence of the general theory of relativity, because we have to adjust for time traveling more slowly for a moving observer. And we adjust for the time difference from a satellite orbiting around Earth to an observer on Earth. So GPS is one example of an application, but there's plenty more. Let's see. Did Einstein ever had a girlfriend? Yes, we did say he got married twice. Let me see. Did Einstein believe in God? That's a good question. As far as I understand, he was an agnostic. He did shy away from the word atheist, but he did not believe in a personal God, like a God, a religious God, so to speak. He had, it's been known that he had, or actually he said that he had a more pantheistic attitude, very much like Spinoza, who was a philosopher who believed that God was everything and in every piece of matter around us. Let me see. Was Einstein Jewish by birth? Yes, he was. Both of his parents were Jewish, and he was born in Germany. And in fact, he had a very interesting story because when he left for Germany, and then he went to Switzerland, and then he came to the US, and he was at Princeton, Adolf Hitler came into power in Germany in 1933. And that's when he realized that most of the professors that were Jewish were being kicked out of universities, and he realized he couldn't go back. And that's why he stayed in the US and helped a lot of people be placed in American universities. So he saved a lot of people. Does Einstein have living relatives? Yes, he does. And we do know that one of his, I believe, great-grandsons was a successful engineer or grandson, I believe. I have to check on that, but we do know that they're living relatives. Let's see. We have just one more minute. Albert, what was his view about aliens? I don't know what Albert's view on aliens was, unfortunately. Sorry about that. I can tell you what my view is, but that's not relevant. Can a time machine take us to the past? Like I said before, nothing can travel fast. Nothing that has matter like us can travel faster than the speed of light. So time travel as we know it now, as we think of it in a thought experiment, cannot happen. But I believe there's no limit, theoretical limit to that. So who knows? Maybe our kids are going to discover something new and challenge our views. Did special relativity theory and time traveling possible? The IQ of Einstein, that's a very good question. As far as popular knowledge, Einstein never took an IQ test. So there you go. We do know that after he passed away, his brain was preserved and was donated for research to see what made him such an incredible genius. And so I don't know if anything came out of that, but it was sliced into pieces and studied quite thoroughly. I don't know what came out. So what is my name? My name again is Debbie or Deborah Berebichez, and I'm a physicist, and I have enjoyed my time tremendously. We're unfortunately out of time. Your questions have been incredible. They're coming still. Again, please leave your comments here on the page and also tweet at us. We'd love to keep in touch. Einstein was a genius and a remarkable man. He was a pacifist, and we miss him very much today, especially in our crazy world. I think he would have enlightened us beyond his physics knowledge. And so thank you everyone for celebrating his birthday, respecting and admiring such a humanitarian and brilliant man. I loved hanging out with you. Again, thank you, and I hope to see you guys very soon. Take care.